anyone not complete this step? No Wi-Fi still? No Wi-Fi, huh? Okay. All right. Well, while they're working on that, we can get started with the theoretical part, I guess. So, my name is Bruno Škvorc, and I'm the CEO of Bitfalls and Coin Vendor. Bitfalls is a tutorial and education company for Ethereum development. So we do consulting, and we do smart contract auditing, and we do smart contract development in general, and so on. And we publish tutorials for development courses and so on. And Coin Vendor is a platform for is an on-ramp for civilians to purchase cryptocurrencies. So basically, just a bank payment and a direct deposit of any altcoin to their wallet. These are our main projects with a couple more in the pipeline. If you want to connect later on, feel free to grab me in the hallway or just find me on Twitter or on any of those two sites. There's contact information everywhere. Okay, so today we'll be talking about, we'll actually be working through our own token creation and ICO process, not just from the technological perspective, but also from a kind of business sense perspective. But more, we'll be dealing with code directly, but we'll explain some terms around ICOs and tokens in general. Okay, so a lot of you have filled out a questionnaire that Tomislav sent you, a form for skill levels, I think it was. And that was very useful, thank you. I would just like to ask you, some people said that they were veteran programmers. Who were those? Like experienced? Okay, what language would that be? Java, C, yeah, okay. Java, C#, okay. Okay, cool. And essentially, all of you said that you have little to no experience with Ethereum development and Solidity in general, so we'll kind of go from scratch there. But essentially, Solidity is a very high-level language that has some static typing. So, like in some of the more enterprise languages, so it has static types, it has strict checking, and so on. But it's still very quirky because it's under development, and it's easy to make a mistake there. So we'll address some of those in the code that we'll be demonstrating if the internet starts working. There's an ongoing idea that whenever a project, who here plans to launch an ICO in the near future? Okay, are the projects planned out and developed, or is it just in an idea phase? Idea, okay. Yeah. Planned out, yeah. Yep. Idea, okay. Okay, that's good. Most people think that when you talk to blockchain, we advise on a lot of these ICOs and so on. So when we talk to these projects, a lot of people tell them, a lot of advisors tell them that you have to tell the audience why you need the blockchain, and if you don't know why exactly, then make something up to generate the hype so that people invest. And this is unfortunately why most ICOs get started, because they want the blockchain hype. They want this free advertisement that comes with the word blockchain. I would say the opposite. Never force blockchain into any project. Instead, your project either needs blockchain really desperately and needs to be built on it, or not at all. And both of these approaches are fine for an ICO. If you have a project that needs the blockchain to survive, if you need it for the infrastructure, that's great, and you have a business case for the blockchain, and your project will probably do well if you advertise it properly. In those cases, the blockchain is a good solution for infrastructure, and if you can document that, that's great. But if you have an application and 96% of the projects out there do not need a blockchain for infrastructure. They really don't. If a private company is behind the project, it usually doesn't need a blockchain. Blockchain is useful for public matters, for matters that need public inspection, for publicly verifiable data, for environments where you don't have trust. In a private company, when you are the owner of the product and you have customers using your blockchain implementation, it makes absolutely no sense to have the blockchain. But you might need an ICO. Why? Because ICOs are the best way to gather funds for your project to date. If I have my neighbor who is a baker who has 5,000 euros saved up and he wants to invest this, I do not want him to have to go through a bunch of regulatory training and inspections and licenses and so on to become an accredited investor to be able to put his money into my business, into my venture. If a person can walk into a casino with their 5,000 euros and put them in a slot machine, I don't see why we wouldn't allow every civilian to invest in any project that they want. And this is what ICOs make possible. So I would argue that even if your project doesn't have a particular blockchain need, you're fine with launching an ICO, and that's completely fine. However, people then ask, why a token? Why a blockchain? Why would you use this at all then? Because what's the infrastructure need? Why would people invest through this if they don't get anything in return? Well, you can give them something in return. A very popular and a very good option to take is share tokens. These are securities in under all investment regulations and laws. But what you do is you take their investments, you give them in return some tokens based on whatever formula you decide on, and then you kind of separate a profit of the company into a pool that gets distributed to the shareholders according to the number of tokens that they have. So you're basically paying out dividends without paying out dividends, and that's a perfectly acceptable way of running a project, of funding a project. We still don't have clearly defined regulations about fundraising this way and about paying out dividends this way, but that's fine because even if you follow every regulation today in regards to ICOs and crypto projects and everything, it can change overnight, as we've seen in countless cases. So I would argue that an ICO used purely for fundraising is also a fine solution, and you do not have to get stuck on looking for a problem you can solve with blockchain in your project. That said, we will be building a kind of a mixture between these approaches. So this token that we'll build will be a usual, just a regular ERC20 token, and ERC20 is first of all, who's familiar with why Ethereum exists and where it's headed? On a technical level. Who's not familiar with it? Okay. So briefly about ERC20 tokens. ERC20 tokens are tokens that have specific. A token is like imagine imagine a table like. All right. So imagine how do I insert a table here? There we go. Okay. So if we have here a name and an amount, and is that updating? Yeah. So a token. So let's start with Ethereum. Ethereum is a project that it's a blockchain that can run arbitrary code. You run programs on the Ethereum blockchain, and when you run them on this blockchain, these programs run on every computer connected to the Ethereum blockchain, which means that your program executes on every single computer. Which means that all the computers connected to the Ethereum network run that same program, that same code at the same time, and they all need to get the same solution. So it's deterministic. There can be no variance between the result produced by this code. And this is very wasteful because you run the same code on a lot of computers, but it's also very secure because you have the verification of many thousands of nodes all saying the same thing. Yes, this program executed like this. Yes, this program produces this result, and hi, other node, does your program also produce this result? Yes. And once all this is confirmed, your program has successfully executed. Now, these programs can be anything, and they are written as smart contracts, which is kind of fancy talk for code that is executed without manual input from other people. So it's code that's executed regardless of other factors. If you program it into the blockchain, it's going to get executed that way and that way only. There's no way to tamper with it. Vitalik, the creator of Ethereum, compared it to a vending machine. If you have a smart contract, so a vending machine is a smart contract where you put money in, you put $2 in, a drink comes out. You don't put $2 in, a drink doesn't come out. So that's very basically enforceable, and that's a very basic smart contract. If this, then that. If this, then that. If not this, then that. And the vending machine is secure enough for $2 worth of drinks, but it's not secure enough to hold a bank vault inside it. So Ethereum in this case is secure enough because it runs on all of these computers. Now, Ethereum in this way is a world processor, so a world CPU. And what we got with it is basically one big global computer that runs programs at the same time. Ethereum has two more parts to it. One is Whisper and one is Swarm. These are two protocols. Whisper is used to whisper between nodes to send messages for communication, so not transactions, because when you send a transaction on the blockchain, it's permanent, it's forever. And it stays there, and it gets saved into the blockchain permanently, and it costs some money some money in gas, in ether, to store it there. Whisper is for temporary messages. So if you need to send a message to all the nodes in the network, you do a little bit of proof of work, so some calculations, and that message then gets sent. This proof of work is spam protection, because if you have a spamming engine, it can't produce millions and millions of messages because it still has to do a little bit of calculating. And these messages can be used to communicate between the nodes. So this is kind of the networking communication layer of the Ethereum world computer. And Swarm is another protocol which explains how to implement storage on the blockchain. So right now, if you want to save some data on the blockchain, that's super expensive. Just storing, for example, one wallet address costs 40,000 gas approximately to store it onto the blockchain. And gas price varies. It's currently at around 5 Gwei, which is 5 gigawei, which is 5 million Wei, and 1 Wei is the smallest unit of ether. There are many calculators that you can use to actually, let me just check if I can connect to this now. Nope. So one Ethereum has, one ether has 18 decimal places, and the smallest unit is 1 Wei. So 5 gigawei is the cost of gas, average cost of gas right now. And these costs of gas are paid every time you need to store something to the blockchain. Swarm is there to make possible saving of larger amounts of data onto the blockchain, so that you basically have, like torrents. If you have a torrent, you basically store a file on the torrent network and it gets distributed to all the other computers. And with that, we have this complete world computer where we have the distributed CPU as Ethereum, which executes programs, the distributed hard drive, which is Swarm, which saves files, and the distributed network and communication protocol, which is Whisper, so you can exchange messages and do temporary communication between nodes. So this is what Ethereum is, a world computer. And smart contracts are programs on that computer. And tokens are just one smart contract. So a token is a program. And in this case, a token is a very rudimentary program, which is basically like a small database, which says who has how many tokens. That's literally it. A token is just a spreadsheet which says how many tokens a person has. So this is basically how a token looks on the Ethereum blockchain. It's a spreadsheet that's written onto the blockchain, and the only people allowed to change their balance are those that have that balance. So only Anne can change her 10,000 to something else and thereby increase someone else's balance. She can only decrease hers to increase someone else's. She cannot decrease someone else's to increase hers. And this is essentially what a token is. Just a way to store how much money someone has in the network. Now, ERC20, which is what most tokens are on the Ethereum network. Let's see if the Wi-Fi started working. Not yet. So ERC20 is ERC stands for Ethereum Request for Comments. Whenever someone comes up with a new idea for Ethereum, they suggest it in their repository on GitHub, and they ask for comments. So let's discuss this. This is my idea for improvement. Let's do this. 20 is for the ordinary number of the request, so it was the 20th request in order in their repository, and people commented, and that they agreed on it, and so ERC20 became a standard which defines specific functions in that contract. So this table will have specific functions in it which can be called by any application. For example, if an is an address, then an will have there's a balance function which can be called like so. So an.balance, and if you call that function in Ethereum, it's going to return 10,000. And there are several such methods. For example, there is also an.transfer, and this transfers, an.transfer, and this transfers any amount of Ether from the account that you're calling it on to the address that you input into the parentheses. So it's just a list of functions that a token must have in order to be ERC20 compatible. And why is this important? Because when you have an ERC20 token, exchanges, which your end goal is to have your token on an exchange, exchanges can automatically read it. If you send your token to submission to an exchange, it's going to ping it with these default methods, with these default functions, to check if it has this information. So does it have the decimal count? Does it have its name? Does it have its ticker? Does it have the functions it needs to have for us in order to use it, to send it to other people, and so on? Yeah, go ahead.
Can we pose questions now or after?
You can ask, whenever.
Just finish the sentence now and then.
So yeah, so the exchanges just read these standardized contracts and take a bribe to list your token into their listings and to make them available to other people. And by using ERC20 standard, you don't have to do any extra work to help them implement it, because most exchanges will not list your token unless it is ERC20 compatible. And that's the token we'll be building today. Go ahead.
Yeah, so I mean, there are known bugs to ERC20 which were exploited. So my question is, and I understand completely your sentence that you need to use it, but then you run this risk if you're setting up an ICO and decide for using ERC20 and not, I don't know, ERC7 something. You know what I'm saying?
Which bugs specifically do you mean?
They exploit you could exploit ERC20 token. I forgot, I read about it, but the tokens were stolen. So the ICO tokens that were issued were stolen because of this bug in ERC20.
Yes, but
if you Google it up, it's I think maybe that was the one.
No, that's not.
Yeah, that's the token. It's about how they organize this multi-signature, and it was like they didn't implement the multi-signature, and then the bug was exploited. Actually, the XC token is a standard, and
we'll actually go through an example of the bug, what happened actually, and we'll see what happened. It's a common mistake, and they fixed it in the code, in the compiler, to warn you about these issues, because it's a very easy mistake to make if you're not coming from a very, very, very verbose and explicit language, which requires you to define absolutely everything. And it made some assumptions that weren't exactly the best assumptions at the time, the compiler, but they fixed it in the meanwhile. The problem is there that, so ERC20 is just a standard. ERC20 just defines which methods, which functions need to exist. So ERC20 just says, your token, in order to be compatible, needs to have a balance function. So a balance function. It doesn't say how it needs to work. It doesn't say what this balance function does. You can implement any kind of logic you want into this balance function. It doesn't matter. What matters is that it has this function, and that this function returns a number. If this function returns a number on that token, that's fine. So you have to kind of be careful when implementing that interface. So an interface is just a rule, a recipe for how a token must look superficially, so when seen from a distance. Does it have this? Does it have this? Does it have this? A car has to have 4 wheels from a distance. If those wheels have concrete in their tires, doesn't matter, as long as they spin, they look like tires, it fits the definition of a car. How effective it is another story, but it matches the interface. So an interface is just a guide on which functions need to exist, and it's up to the developer to develop this properly. And in order to develop these tokens and contracts securely, a lot of helper libraries have popped up that you can use, that are essentially almost like copy-paste templates that you can use to develop your own token. We will be using one such template, and we'll also be developing our token from scratch to show you what exactly is being done and how you can get to know the code a little bit more in depth. The beauty of Solidity and smart contract development is that it's so different from traditional development that even people who have had 0 experience to programming before can pick it up just as fast as veteran programmers, because you basically learn everything from scratch. There's very little overlap, maybe some object-oriented programming, nothing extreme, nothing you can't really pick up in a relatively small amount of time if you put your mind to it.
And what is this amount of time according to your judgment? I mean, if somebody decides to pick it up?
You can, if you make it a full-time effort, you can be ready in like 3 to 6 months to write your contracts without any critical bugs easily. Every token, every ICO that gets that's planning to launch should always be audited. So security audits are very important, because as a developer you become blind to your own mistakes. You keep looking at what you did and your brain just skips over some holes that are obvious. So just having a second, third, or fourth pair of eyes go through everything you wrote can be really critical to the project's success. And this is a very important part of ICO and token development in particular, because teams are usually rushing to push their ICO to the market, and in doing so they publish their contracts maybe days before the ICO's launch. Since people don't actually trust ICOs that don't publish their source code of the project, what happens is that 2 days before your launch you publish your source code. Nobody has time to properly audit it, but those people who understand what's going on, who know Solidity, will check it out, will notice your bugs, and will wait for your ICO to launch. And then they'll siphon off all of your ether that's coming in, or destroy your project just because you didn't publish your code early enough, set up bounties for bug rewards and so on. So it's an important part of every ICO to launch months in advance, to set up a bounty program, to get a good security audit going, preferably by 2 different companies that are unrelated, and just to make sure that this, because after all this is the entire future of your project at stake. Not only can you lose your funding, you can lose other people's money in the process on a stupid mistake, and it can be very expensive for everybody. So this, you should be very careful about that.
So when we say one token, does it mean exactly one smart contract or more?
Yeah. In general, a smart contract, so smart contracts on Ethereum are designed to be as atomic as possible. Your goal is to have several smaller contracts that have very specific purposes. Why? Because it's impossible or very difficult to update code on the Ethereum blockchain. Once you deploy code onto the blockchain, there's no way to remove it. There's ways to kill a contract if you implement such a function, but the contract will still live there. It will remain. And if people keep calling your functions on that contract while it's still dead, they can still do that because the address still exists there. So they can still send ether into emptiness and so on. So your goal is to have really small, really encapsulated, really atomic contracts that have one specific purpose. So we'll develop 2 contracts. We'll develop one that is an ERC20 token, and that's going to stand on its own, and we'll be able, if we can get connected, we'll be able to send it to one another. We'll be able to use it just as a regular token. From our computers, we'll be able to send tokens to one another, trade with them, and whatnot. And the other contract will be an ICO contract to which we'll send those tokens. So, for example, you'll have an ICO which says anybody who contributes this much ether will, from now on, will get, for that ether, will get an appropriate amount of tokens. And the ICO will kind of act as a wallet for the tokens. We'll send the tokens to the ICO. The ICO will take payments in ether and will return to the sender that amount of tokens. But we'll add a twist, we'll add a delay so that the buyer investor does not get the tokens immediately. Why? Because when you send tokens out immediately, you're opening your project to the vulnerability of a dumping on the exchanges. A lot of groups, actually organized groups, exist that invest a large amount of ether into your token before you actually publicly launch. So they actually buy in the tokens in your pre-sale period or just as the ICO starts. And what they do is immediately as they get the tokens, they dump it on exchanges that support them. Why do they do this? Because if they invested early enough, they got a bonus. So they got it cheaper than the default price after the ICO. And they can turn a profit just by flipping this token. So these flipping groups exist, and they basically ruin projects by buying the token cheap, selling it immediately after the ICO is done, and then crashing the price. And the token crashes so far, it never recovers. And immediately the team has less money than they plan to have, and they have a harder time getting development off the ground. So a good idea is to develop an ICO which has a gradual release. For example, if you take a 1-year release schedule, then you can release 12% or however much, 8% per month until all of it is released throughout the year. So you allow people to withdraw 8% of their invested amount of tokens once per month in that maximum amount. So they can only dump 8% at a time, and this will not crash the price. So this is a much better approach, and they still get something, but you basically count on people's long-term investment in your project. This makes it much harder to get a full ICO hard cap gathered. So it makes it much harder to get all the ether that you want, because a lot of the ICOs that do beat the hard cap are beaten actually by these flippers. So it's actually huge investment groups that go into the ICO project with the express purpose to buy as many tokens and dump them immediately after the ICO. So it's going to be much harder to gather funds, but it's going to be much healthier for the project long term. And I should also note that any ICO that's launching, any token that's launching, any project, unfortunately, 90% of the success will depend on marketing. Your code quality, your project's idea, none of it matters. It's all marketing, unfortunately. It's all, you have to kind of put aside, I think now we're in the 200 to 500,000 euro budget range for advertising. You will have to bribe a lot of web portals. You will have to bribe Cointelegraph and Coindesk take 1 Bitcoin to publish your promotional post. Sorry?
How much money you say the marketing budget on average?
200 to 500,000 euro. Yeah, because as Google, Facebook, and Twitter banned ICO ads, the portals have found a way to kind of cash in on that. And everybody raised their prices, their bribing prices, for publishing posts about ICOs. They usually take 1 Bitcoin, Cointelegraph and Coindesk take 1 Bitcoin for your post, for your press release, just to publish a press release. For an actual post, they take more. There's YouTube influencers you will have to bribe. There's Twitter influencers you will have to bribe. There are upvote armies you will have to buy on Reddit. None of it is honest. None of it is fair. There is no legit marketing in the ICO space anymore. None of the projects are legitimately advertised as none of the projects gather funds based on their quality anymore, because the market is so saturated. It's all about how many eyes you can get your project in front of. And that's a sad reality that I hope changes soon. So when you're starting out, it's a good idea to get a pre-investment round ready so that you have some money set aside for this marketing. And when it starts, you go all out with the marketing. So be ready to spend the €500,000 you set apart on marketing in that 1 month. Be ready to bombard the entire ecosystem, the entire media space with your project. Pre-purchase ad slots and everything in advance, and just be ready to launch it full on, because people will forget about it. You can have extra success if you actually have a demo, a minimum viable product ready before the ICO, so people can test something and then see, wow, this actually works, and then invest, because then you get some free advertisement from that. People will say, look, this is one of the 3 projects in the world that actually has a product before an ICO, and that's a good way to advertise. But you will have to spend hundreds of thousands of euro on advertisement unless you already have huge influencers on board. Even ICO advisors who never ever actually contact you once you put them on your website will take whole Bitcoins from you just for their face to be on that website. So ICO advisors are more often than not just faces on your website. They will never advise you, actually. They will just be there as someone who basically said, yes, I allowed my face to be there. So it's a very cutthroat space. It's very, very, very difficult to get this funding. So be ready to go all out on the marketing budget. I don't want to discourage you too much, but I do have to be real. Yeah.
Can I ask a question one step back? You said that if they dump your token price, they destroy your project. I mean, I don't see actually why, because we are now in the middle of launching an ICO, and you set up a soft cap, and it should be honest. So you need a 6 million to develop something, and we should be honest. I mean, by
Yes.
so you gather an ether, so for in amount of 6 million, let's say that. So this is the money you will pay for services. So
Yes. Ether. The gathered ether stays, and that's cool. But very often teams keep a big chunk of the tokens for themselves, and this is intended as a budget for further development once the ether is exhausted for the initial development. And in that case, these tokens that are waiting to be distributed to the team later on are now devalued, so they are worth less. So you automatically have less runway for your company because your tokens are worth less and you have less money to pay out to your developers and to your people. Furthermore, as people grow disillusioned with your project because they are new bag holders, so they are new holders of these now much more worthless tokens, they will leave your project. So as their investments crash because those flippers have dumped their investment, they will actually turn against you and either start an anti-advertising campaign against you or just leave altogether. And you lose a big part of the community. And the community is absolutely essential for any ICO token project because you need this liquidity of people using your token, sending it around, even just as a store of value to keep it somewhere. You still need people. And if people leave because people crashed that token, and that happens, you are in a big bunch of trouble. How many of you have heard of SIA coin?
Sorry?
SIA coin. Yeah.
Only heard.
Yeah. So SIA coin started years ago. It's its own blockchain, and it's one of the first approaches to storing data on the blockchain in a decentralized way. It works kind of like torrents, where you set up a node, but you're renting your disk space to store this data to other people, and you're getting paid in SIA tokens. They actually they were the first ones to have a working product. Their product does work. The rising popularity of the token did cause them some scaling issues rather recently, but years ago they had a working product and people could use it. Their marketing was abysmal. They didn't have any marketing at all, and their token was in sub-cent value for years. Along came Filecoin, a project which is still just a PowerPoint presentation today, more than 1 year after its ICO, and they gathered in seconds hundreds of millions of dollars. Why? Because they invested millions into marketing. They had nothing, and they gathered hundreds of millions because they had a promise and influencers making that promise for them. SIA coin had absolutely no marketing budget, and it shows. So they are still suffering. They are doing well today relatively compared to their past performance, but this is a clear example of how much marketing here means. SIA coin will eventually do better once they kind of fix this community outreach side and do some more marketing, but I'm just saying that it's quite obvious that the product doesn't matter in the fundraising stage. In the fundraising stage, all that matters is unfortunately marketing. And that was a year ago when ICOs were still relatively kind of honest, so Filecoin succeeded then. Today, it's much harder. So that's just an example. And you do need this community. So SIA coin actually suffered huge losses in community. It had a huge community base when it started, and people left because the price kept going down. Nobody heard of the token. There was no outreach. nobody was buying it, and the price kept going down. As the price kept going down, fewer and fewer people were renting their disk space for storage, fewer nodes were active, then their blockchain started dying because nobody was using it because it just wasn't profitable. It cost more money to keep a computer on and host other people's files than they had the chance to earn because the tokens were dropping in value. And this is a huge problem. So you need a community, you need an important community, and you need to protect your investors from dumping and from this market manipulation.
This all depends if you have a fixed price for your service in your tokens. But if you don't have a fixed price, then it almost doesn't matter what's the value of the coin.
It depends on how you set up, the pricing structure. Yeah, it depends. It's just that SIA is also mined, so you can't really say it's $100 to host this, and then one day it's 1 million SIA tokens, and another day it's 2 million SIA tokens. There's just not enough SIA tokens to go around. Yeah.
In other way, I don't see that. I mean, especially if it's a utility token, it's just
Yeah.
The main problem I see, I mean, if you didn't calculate the soft cap in a way that you can survive without any token, then you probably calculated the soft cap in a wrong way.
I agree. That's why the business side is very important here, where you have to lay out a long-term plan for your project, funds-wise and return of investment-wise. You can't just, a soft cap of 7,000 Ether will give you 4 million euro of runway, but you have to have a plan for when that runway runs out. And when
then you have to already have product in place,
yeah,
start generating the cash
yeah,
flow
that's
for your
what,
regular service.
yeah, that's what I'm saying.
That's
So
why I think also the names are misused a lot in terms of tokens and stuff. How many I compare utility token to the Tesla 3 voucher. You know what I'm saying? So it's the same thing. Tesla 3 issued the voucher for crowdfunding the further development of the car. So if you ask Elon Musk how many voucher it has in the drawer for Tesla 3, probably none. So here it should be the same. It's a different story for security token. I agree, but utility token is just a voucher for the service, for the future service.
yeah.
It's a digitalized Kickstarter in a way. You know what I'm saying? So
It is, yeah, it is.
This talking about the honesty, this is how people should behave, but now they don't.
Yeah, they
and
don't.
That's why we have huge problems. The honest projects have huge problems because of those dishonest promising, returns on investments and stuff, which is pure bullshit, excuse my French. So
Yeah. Correct. I have managed to connect to the Wi-Fi. Anyone else?
How long? Yeah.
2 minutes and counting. I have a whopping speed of 10 kilobytes.
Connects, but then it disconnects after.
This happened I had a workshop in another town a few months back, and the same thing happened.
And what you did?
I was developing locally and just demonstrating stuff, which I can also do here, but it's not the same thing. I wanted everybody to have hands-on experience, and it's not a workshop, it's a presentation.
Okay, we will get payback in coins.
Block
do you
split
need
coins.
Internet or intranet?
Sorry?
Do you need like internet or intranet?
Both. Ideally, 1 hour of internet would be fine.
So then I can share you mine and it can work.
Yeah, but everybody needs it to download the tools.
And how big it is?
It's not big, but you won't be able to connect more than five people to your tether.
Yeah, but we can pull some.
We can at least watch, on your screen. So
Yep.
at least something.
After everybody's done with the downloading, can we just do we just set up a thing and we just do our own network?
That's the plan. That's the plan.
Okay, so
We'll have everything will be local once we download all the stuff that's needed. But we will need internet periodically because we need to pull in dependencies and packages, and
okay.
then it's going to be.
We have the local network here where we can.
But do you have it in your server so you can
Because one
set up?
can download, put on the local network. We can just
It should be block split. It should be block. They promised me it would be block split, but
You have all the stuff in your.
I don't have the binaries that I downloaded.
Okay.
Let me check actually. I do have the most recent MIST. Let me see if I can share this. Yeah, but we have no way to connect because there's this thing, which is yeah, you know,
Still be quick.
yeah. I mean, but it's a super ancient ubiquity.
You need it, so I mean, I have it. If you want, I have no problem with sharing.
You can share.
Just let me know. I don't know, whatever you prefer.
I would like to be able to share with all of you at least my public folder so that I can put the binaries that I do have in there. But I only have MIST, not geth, and it's gonna be, let me check. Okay, yeah, it works for me as well. Give it a shot. It might work.
Excuse me.
Yeah.
Should we install get and development tools or just get?
1 second. Let me check the.
I'm on Windows.
Download development tools as well.
You just need to run get in private.
Yeah, we'll do that. Don't. Did you download it?
I have done that before.
Okay, cool. Do you have the up-to-date version? Which version is yours?
The colleague
It should be 010 is missed. Geth should be something like 1.8 point something. Yeah, okay. Right.
yeah.
All right. I will also download Geth Darwin. Okay. Downloads. All right. Is it working? Yeah. Yeah. All right. Cool. Guess we're getting
Or
somewhere.
what? Maybe we can do that after lunch. The stuff that now discussed and prepared for better.
Yeah.
To get questions and
Let me just. Okay, I downloaded. All right. I've downloaded Geth and MIST. I will try to share. I'll try to share them on the network, so you can also pull them from my public folder if that'll help. Public. All right. This is not needed. Downloads. Geth and MIST. Public. Sharing. It's working?
No, the blocks of interest
Okay, nice.
This Ethereum wallet missed.
No, MIST, not Ethereum wallet, MIST. Yeah. Because Ethereum MIST is actually a program, MIST is a program which is used to browse decentralized applications. It's actually a browser with a custom interface. It's just Chrome with a custom interface. And it's an interface to the Ethereum wallet. So it connects to the Geth in the background. Geth is like the Go Ethereum. So it's the Ethereum client that's written in Go. and that's your Ethereum node. So that's what does the mining and the transaction and so on. Mist connects to that and reads from the contracts from Geth. And you can also use it as a regular browser. If you download the Ethereum wallet version, then it's locked to be just in an Ethereum wallet. You can't load other dApps through it, other decentralized dApps. But if you download Mist, you can load other dApps. The Ethereum wallet software is there for users so that they don't have to download the development version and so that they don't have the chance to open a malicious decentralized application, because dApps can do a lot of weird stuff while they're still in this beta stage. So the Ethereum wallet is for end users and for people who don't develop, and Mist is for people who need to experiment and develop stuff in Mist. You should be able to see my public folder if you haven't been able to download the binaries to install Mist and Geth. You should be able to see me on the network, Bruno's MacBook Pro. Who hasn't?
Can you type your network share?
Sure.
Because I don't see it, maybe I missed just access.
Let me check. This should be it, if you don't. Who hasn't installed the binaries yet? The Geth and Mist? Okay, 2 more. Right, while we are waiting for 2 more installations, let me just show you real quick this tool, if the internet still works. I'll introduce some tools now that we'll be using briefly. Oh yeah, you'll need to download some other stuff as well, probably, if you don't have it. It might work. Oh, there we go. So, okay, what is this now? All right, so, okay. So this is a browser-based code editor for Solidity. So this is for people who don't want to run their private blockchain, or can't, or for debugging and experimentation. So this is a decent tool to write Solidity code. It's not a fully fledged environment where you can actually develop your project from scratch and to completion, because it's missing some important details like testing, like like running transactions from and to various accounts, like importing other contracts so that you can extend them, so that you can import someone else's contract template, extend it, and modify it to your liking. So, but this is great for testing, and we'll be using this to demonstrate something later on. But I'll just briefly cover the, so this is the template contract that gets opened when you open Remix. I'll briefly cover the, some of the syntax for Solidity. So when you start a new Solidity smart contract, every contract has to have the pragma line at the beginning. and the pragma line declares which compiler is being used to compile this code into EVM code. So Ethereum Virtual Machine needs to know which version of the code it's running. So in this case, this is 040. The most recent one is 050, which has some breaking changes. We'll be using 0423 or something here, but I'll explain the differences. This is the first line, and it absolutely has to be present in every smart contract. Every file can have several contracts inside it. It doesn't matter how many there are, but every contract must be separated from the rest with the contract declaration, so a contract. And what follows is the contract name, which is usually in uppercase. So this is like in object-oriented programming. I know not a lot of you have experience with it, but basically this is like the name of the program. That's it. Then there's the curly braces, and in between curly braces, all the functionality and logic of your application, of your smart contract will live. So it supports several data types, only some of which we'll be using today. Structs are the kind of they're not exactly as necessary in Solidity as they might be in other languages. They're kind of a workaround in Solidity, because if you don't know how to declare a piece of data, then you'll put it in a struct. A struct is basically like a custom type of data, custom spreadsheet inside your spreadsheet. So in this case, we have here a voter struct. So this is like a mini contract which only stores information. And there are several types of data you can save and use in Solidity. uint means an unsigned integer. Unsigned means that it can only be a positive number. uint is actually identical to uint 256, which is a 256-bit version of the number, so the biggest variable box in which you can store a number. So this is for big numbers. Weight, so how much voting power a user has. This is arbitrary. You can name these variables, these parts of a struct. You can name them whatever you want. Bool is Boolean. This can only be true or false. uint8 is a smaller version of the number, so vote. And address is a special type of data which stores the Ethereum address of which stores an Ethereum address. So in this case, it's going to be the Ethereum address of the voter. But in general, addresses can be internal or external. Internal addresses are addresses of the Ethereum blockchain itself. So when you deploy a contract to the Ethereum blockchain, it will get deployed on an address. And in order to call some functions in that other contract, you will have to know its address. And we'll show how you can communicate between contracts later. The address and an external address is the address of a user. So this is the address that everybody uses to store their Ether tokens and so on. So it's the same format. It's just two types of addresses that don't actually, the difference doesn't matter in Solidity itself. Struct proposal, this is pointless, okay, whatever. Okay, then there's mapping. So a mapping is like, is literally a mapping between one value and another. So it's a list where you have two columns. One is the name of the column, and the other is the value of the column. In this case, this is a mapping of addresses to voters called voters. So this mapping is called voters. And what this part in the middle means, it means that this is going to look like a table, like a spreadsheet, where one column is addresses of people, and the other column stores the voters that we defined earlier, so the structs. So one column is going to store their addresses, and the other is going to store the voters. Now, why might this be necessary, since the voter itself already has its own address inside? Because we might need to look up a voter per address. There's no way to look inside a list of voters and just pull them out by their address. There is, but it costs money. You would have to loop through all the voters that you have in the system, and then you'd have to check their address one by one and return the one that you're looking for. In Solidity, the more computation your program does, so the more work it has to do to get to a result, the more expensive it is to run that transaction. For example, summing two numbers in Solidity, so 3 plus 5, will cost 3 gas. Multiplying 3 times 5, multiplying two numbers, costs 5 gas. So if you have many multiplications or many summations, you get a more expensive transaction. So it's usually worth it to do as much calculation as you can off-chain, so in your application, on your server or in your client side, whatever, and store only the results in the blockchain, but results in such a way that they can be used to verify those calculations. So you don't actually, the end goal is to have as little calculating and as little storage of raw data on the blockchain as possible, and instead focus on deterministic and just static values, storing just the state of your program in the blockchain and not doing a lot of logic in it. So loops, when you have to loop through something, that also costs gas. And the more loops you do, the more expensive it is. And if you have a lot of elements, and if you have no upper limit to how many elements you can have in your collection that you're looping through, you might run into a problem where looping through that collection costs more gas than you can actually send in a transaction. Because Ethereum has this site is very useful. You can see how much gas maximum a transaction can cost. And in this case, it's currently above 8 million. Ethereum is defined to, is kind of built to automatically scale. So if the blocks are too small, so if this limit is too small and a lot of transactions that are bigger than this keep coming in, Ethereum will auto-scale. It will automatically increase this limit until it starts processing most of those transactions. Once it does, and once the transactions are lighter than the limit, it will automatically start decreasing it. This happens very slowly, but it happens regardless. So there's no block size issues with Ethereum. So in this case, your transaction must not be heavier than 8 million gas. That's a lot of gas, but as you'll see, that's not exactly hard to break this limit. That's very little calculations that you can do in that one limit. I think our transaction to create the ICO will be around 2 million gas, which means that if the blocks ever decrease so that the gas limit becomes 2 million, our transaction will not be able to execute. You will not be able to launch your ICO. And in that case, you will have to break up your ICO into smaller contracts or decrease the transaction for launching, like maybe, because in our ICO, we'll do one transaction that does everything. But when the gas cost becomes too high, you then have to kind of split it up into several sub-functions. So one transaction will upload the ICO to the blockchain. One transaction will set the start time of the ICO. One transaction will set the ratio of Ether to tokens. One transaction will set the end time, and so on and so forth, until you set up your ICO completely. So this is something to keep in mind. So that's a useful site to keep in mind. And right, so there. Oh yeah. So next up we have functions. So functions are the functions that I talked about. For example, in tokens, a function will be called balance off. And this balance off function will return the balance of a given address that has this token. So you will have, for example, if the token address, once we deploy the token, if the token address is something like this, then in order to find out what the balance of a user is, how many tokens a user has, you will do it like this. So you will call a function on this token, and you will put in the address of the user. And this will return the number. This will return how many tokens Joe has. So this is how functions are called on other contracts. So in this case, this function, function ballot, shares the name with our contract. And what this means in programming terms is that this is the constructor. A constructor is a function that is automatically called when the contract is deployed. If the contract is called the same as the function, then that function will be called when the contract is deployed. This is just a kind of a shortcut to so that you don't have to deploy the contract and then call the function. This happens automatically. And in Solidity 0.5, you no longer have this. This is deprecated. So you no longer use the same name of the function as the contract, but you use this. So constructor is literally constructor now. That's one of the major differences with 0.50. as this so since this happens immediately as the contract launches, you see here between parentheses that it has uint8 num-proposal. What this means is that in order to launch this contract, in order to deploy it on the blockchain network, we have to give it an argument, num-proposals, which has to be a number, so uint8, so an integer, an unsigned integer. Num-proposals, so this underscore at the beginning of the variable, this is just a convention, this is an agreement in the Solidity circles that whenever you're using arguments that come into functions, you use this underscore, so you can differentiate them from the variable that you store in the contract itself. Okay, we'll talk about these modifiers a little later, and yeah, okay, it's pointless to explain this like on theory right now, but essentially this is all there is to it, and you see here a total of 66 lines of code for a full contract, for a full smart contract. Now, if we try to, we can actually deploy this in the browser to the JavaScript simulation of a. So Remix has this useful feature where it simulates the blockchain as JavaScript in your browser, and if you click this, if you select this, you basically get 5 addresses auto-generated, each with 100 simulated ether. So you can actually deploy this contract from this address, from one of these addresses that you select. The gas limit here is the gas limit of the blockchain. So when you're running your own blockchain or when you're running a simulation, you can artificially force a gas limit. So what we saw earlier, 8 million, that's automatic by the blockchain. But in this case, we can define, no, gas limit is 3 million. And this is useful when you're debugging, when you're trying to make sure that your transaction does not exceed a limit. This is the value that you send along with your contract. So not only can you execute a transaction, you can also send ether alongside executing a transaction. So you can call a function, but also in the same move, send ether along with the transaction. This is useful for some specific functions we'll mention later. And down here, you select the contract that you want to deploy. In this case, there's just one, this ballot. And you see here, in Remix, you have the red button and the blue button. When you're reading data from the blockchain, reading is always free. There's no cost associated with reading data from the blockchain. Because the state is permanent, you're not doing any changes to the blockchain, so a transaction is not necessary. And that's why it's free. On the other hand, when you're deploying something to it, like a contract, or when you're changing a value in a contract, or when you're doing anything that changes the blockchain, then you have to send a transaction and pay the gas cost. That's why the create button is red, because it will deploy the contract to the Ethereum network in the browser that's simulated. So, and you can see here that it's asking for the number of proposals that we saw here in the constructor. So it's asking for this argument. It cannot launch the contract before we give it a number here. So if I give it the number 10 here and click create, now it created our contract. You can see the output maybe down here. Okay, so you can see here creation of ballot pending, and this is the Ethereum transaction that happened. You can inspect in Remix these transactions that you execute, and you can see here that this one smart contract of 60 lines of code, to save it on the blockchain, to launch it, it cost us 620,000 gas. So over 500,000 gas just to launch a contract of 60 lines of code that does virtually nothing. So you can imagine how much more gas a complex ICO contract can cost. This contract is now launched on the network, and it's launched on the address here. You can't see it in full, but you can copy it with this note. So we'll copy it. So basically, this is the address to which the contract got launched. So this address does not match the address from which we ran the transaction. This is the address of the contract on the network. And if you send money, if you send ether to this contract, the program that we just wrote, the ballot program, is the one that will get the ether. If the program has no function to return this ether to you, it is lost forever. There's no way to pull ether out of a program unless you have programmed in an option to do so. So this is also where people lose a lot of money, because there's no refund mechanism in ICOs, and ICOs go wrong, and then there's no refund. And our ICO will have a refund, which can happen if something goes wrong, so an emergency trigger, red button. And also, if the soft cap isn't reached, people will be able to request a refund back from the ICO. This is an ICO that we recently ran here in Croatia. It also failed to reach the soft cap, and the refund mechanism was responsible for people to get their money back. They had to call a function. I put out a guide on how to do that, and they had to run a transaction on that ICO, and that ICO returned their money back to them.
What was the ICO?
Crypto Hunt. That was an augmented reality game where the founder basically ran away with the money after he collected in the second ICO on the side by not telling anyone. So the first ICO failed, and without telling anyone, he started collecting in a private address for ICO2 and basically disappeared overnight.
Croatian guy?
Yeah.
What the fuck? Sorry.
Yeah. Google Crypto Hunt. Actually, on bitfalls.com, you have a whole post-mortem about it. I wrote a declaration about it just to be clear and transparent to other clients what happened. And I mean, our contract worked perfectly. It refunded all investors. But since he was collecting the second ICO onto a private address, he could run away with the money, and there was nothing we could.
AR.
Sorry? Yeah, AR game. Yeah. I mean, AR. It was kind of like Pokemon Go.
Yeah.
Yeah.
I heard.
So
Money? Just like off the record?
he ran away with I think 200 ether, which is definitely not enough to disappear and get a new identity. So, and I think he's still running, and I think he borrowed around 500 ether from some shady people. So I think he's gonna have a hard time running.
Right, this is how it's supposed to be. You should get, into the river.
Yeah.
Like back in the old days, when the baker was cheating, they put him into the river for,
Yeah. So, right, let's continue. When you launch a contract, especially in Remix, it's going to read whatever code you wrote here, and it's going to automatically make the functions in that contract available to you. So in this case, we are automatically getting these functions that we built into the contract available, and we can use them. We're not going to use this right now because it's not going to be very clear, but we'll come back to this and we'll experiment with it. So this is Remix. I would also like, now that the internet is working better, I would also like you to make sure that you probably do have this, but you have to have a recent version of Node.js and NPM installed, unfortunately. I really, really dislike JavaScript and the JavaScript ecosystem in general. Unfortunately, is necessary here, and we're not going to be able to work without it. So you do need to download. What is this? Is it org? All right. So please download Node.js current, or even LTS. Who cares? Just download. If you don't have Node.js, download a recent version and make sure it's running. Because we'll need it to pull in some other dependencies. Our project will depend on other people's work to some extent, and we'll need to use these tools to use these. And also we'll be using a special...
10 or 8?
Sorry?
10 or 8?
Doesn't matter. I think 8 is more stable.
Okay.
I have no idea which one I have. I have 961. I have no idea how I got 961, but yeah. And I think I have NPM 560. Yeah, 560. So if you have these, that's fine. Once you install Node.js, because we need Node.js to use a tool called Truffle, and Truffle is a sorry, one second. Truffle is a framework, and a framework is just a collection of tools, of libraries, of software that provides some helper methods to debug, test, write, and launch your smart contracts. You can use it to do automatic deployment to the development network, to the test network, to the main network. You can use it to run test suites when you're testing your code. It's basically just a tool to get you started quicker, and it offers a very helpful set of templates, even user-submitted ones, where you have some contracts already made for you, and you can just alter them to match your needs. Usually not ICOs, because those are pretty standardized already, but there are some decentralized application that for example, these templates for Truffle are called boxes, and you have some boxes that already include Vue.js, front-end frameworks, the HTML for a website. So everything, once you unbox this, once you install it, you basically have a kind of a Hello World web app on Ethereum ready to go. It's not a token or an ICO, that still has to be done manually, but these are very helpful when you're building something like CryptoKitties or similar applications that need a web interface to the blockchain. Okay. So when we'll be launching the ICO, we'll be launching it to our own private network. In general, when we're launching, we'll also be launching to the testnet, which is a public testnet. So Ethereum has several testnets, which are public, and they are actually being mined just like regular Ethereum. The only difference between the Ethereum testnet and the mainnet is that we all collectively agreed Ether mined on the testnet is worthless. So this also demonstrates the power of the community. We all agreed that the Ether mined there is worthless, and that's why we use it for testing, even though it's the exact same method of obtaining it. You also have to mine it, you also send it around, you also use it to power transactions and so on. But we just agreed that, okay, this is not real Ether and this is real Ether, and that's the way it works.
Just monopoly money.
Yeah, just a lot of free and zero worth money, yeah. And so we'll be deploying to a testnet, but in order to do that from the local machine, you would have to actually copy the entire testnet blockchain, which is over 100 gigabytes, and then run the guest node and so on. That's why a more common approach is to use Infura or some other similar service. And Infura is a company which offers node as a service. And they are hosting Ethereum nodes on their servers, to which you can send your requests and transactions. So what we'll do is we'll deploy our contract to their testnet node, and their node will send it around to the entire world's testnet blockchain for Ethereum. So it'll be like we deployed it locally, but through them as a proxy, so that we don't have to download everything and run everything ourselves. If someone is accustomed to using VMs for development, like I'm a big fan of writing all software in every program I write, every web application I write, every smart contract I write, I usually write in a new Vagrant machine, a new virtual machine, so that my main machine remains clear of dependencies and of runtimes and so on. If you're using that, you can use that fine. Just make sure your network of the VM is shared with the network of your main machine. And if you've downloaded now Node.js and NPM, and if you've downloaded and installed Geth, we can get started with generating our Genesis JSON file. Every blockchain, when it starts, has block 0. So that's the first block. That's called the Genesis block. In order to generate the Genesis block, the blockchain, the node that generates it, needs to have some rules in place, which will tell it how that blockchain works. You can write this file, this Genesis file. It's just a JSON file of a JavaScript object file manually by hand. It's very simple. But you can also use a tool called Puppet. So it's called Puppet. Can I make it? Yeah. Okay. So this is the tool that we'll be using, and you should have this installed if you installed Geth. It should be present already. So for starters, let's do it. Let's do this. All right. Right, let's make a new folder in which we'll be building our blockchain and everything else. So please make a new folder and enter it. And now in this folder, we'll, is everybody there?
Yep.
Yeah? Okay. So now in this folder, we'll be making 2 more folders. Everybody will be running 2 nodes. You can also run 1 node. I don't really, it doesn't matter, but 2 nodes are useful because you can also then play on your own with this because you have 2 nodes working together. You don't have to depend on other people on the network. So we'll make 2 nodes, but first we need 2 folders into which these nodes will store their blockchain data. Let's call it data 1 and data 2. Okay, so the next thing we got to do is we have to, when you have a geth node running on your computer, it has to run with a specific Ethereum address, because if it's mining something, then it has to have an address to which it will deposit the ether that it gets. We will be using, how many of you are not familiar with the proof of authority model of consensus? How many of you are familiar with proof of authority? Okay, so proof of work is the default mode of mining in Ethereum, Bitcoin, and so on. So you do a lot of calculations with your computer. This uses a lot of computing power. Some math is being done, some guesses are being made, and whoever guesses the number is being guessed. He gets the mining reward, and that's it. We could do mining in our private blockchain, but this would kill all our computers. It's very resource intensive, and it makes no sense really in this regard, because proof of work is a competing game. Miners compete with each other to get the first solution, and we are not competing with each other, we're working on a project. In this case, proof of authority is better, because we will select a bunch of nodes as validators, as block sealers. What this means is that specific addresses have the ability to confirm transactions. In this case, it's going to be all of us. They have the ability to confirm transactions, and once the transactions come into the blockchain, those that have the ability to confirm it will be one of those will be randomly selected. That node will confirm the transactions and get the transaction fees from those transactions, and the others will then read their confirmation, confirm that the confirmation is okay, and we'll have the next block, and so on. So this is called proof of authority, and it's how Ethereum's Kovan testnet works also on proof of authority, because a testnet doesn't depend on this anonymity. With proof of authority, you kind of, in public networks, you have to give your identity. A proof of authority is useful for example, airlines are a cartel, and airlines work together to keep the prices up so that there's no competition. If they moved to the blockchain, they would have an excellent use case in proof of authority. Why? Because every airline company could be one authority confirming transactions. They could share data without having to trust each other, and as soon as one of the authorities breaks some rules, so confirms the wrong transactions, they can be kicked out. Since it depends on their identity, on their authority, they no longer have any right to rejoin the network, and they have been excluded from cooperation by these other companies. So this is ideal for cartels and for testnets and for private blockchains. So banks, airlines, hospitals, any kind of institution that can reliably identify its actors without exposing them to any risk. So this is definitely not for people, for everyday users of Ethereum and cryptocurrencies in general. The proof of authority mechanism in Ethereum is called click, which you'll see by Puppet, which will ask us to generate this. But in general, so when Geth is mining, you have to have an account, and to have an account, Geth will generate a key store file. This key store file will hold your wallet on your computer. This is why you maybe heard that some people found Bitcoin on their old hard drives. This is how they found it, because a node that's running on a disk will generate the key store file for that wallet on that disk. And if you lose that disk, you lose that wallet, unless you stored that file somewhere else. So we'll generate those key store files now. To generate this, you have to you have to run get, and get needs a data dir selected. So the data dir parameter flag tells it where the data for this one node will live. That's our data1 folder. And then we'll just put account new. So account is just the general namespace of account functions, and new means create a new account. So once we do this, it will create a new account in the folder, and it will ask you for your passphrase. You can leave this empty, but this can lead to problems because a lot of wallet interfaces, like MetaMask, for example, they require you to enter a password when you're importing a wallet. And if you leave it empty, there's no way to press enter on an empty field. So it's best if you use some kind of a really easy to remember password here, because we'll be using it a lot. For example, I'll put mynet internet 2. All right. So now the account has been generated, and Geth will output the address that it generated for you. So this is the address between the curly braces. This address is missing the 0x prefix. So the real address is actually this. The real address is this, but it's kind of showing just the later part. This is 1. So we'll repeat the process in the other folder as well. So just repeat it in data2 as well, because we need 2 accounts. You can use the same passphrase. And we now have 2 addresses. It is recommended to save these addresses somewhere in a text file or something, because we'll be referencing them several times in the project, and it'll be handy to have them around for easy copy pasting.
Sorry.
Yep.
How have you installed Get? I mean, because I have 2 files.
Brew install get. You have brew.
Okay.
Yeah, do you have Brew?
Get.
Which version does Brew install?
With brew.
Yeah,
Brew is pouring 1.84.
cool. That's great. Awesome.
I have some error while I'm installing it.
Which error?
Some key is longer than I can repeat now.
Key is longer. Oh. Let's see.
I started to download again, maybe the file is corrupt. So just only get one.
Okay, just get.
No,
Fine.
si è scaricato direttamente fai brew install, ce l'hai ti serve Mist.
Maybe it's my local variable.
Yeah, your environment variable path is too long.
So what, shall I just remove something or?
Yeah, you should probably shorten your path variable.
You do the same for data 2, exactly.
Exactly the same, yeah.
You do one and then the same.
Yep, the same thing. Yep.
Because it's installed now, so I can just update my environment.
Yes.
I know where it is.
It should be
Program file.
not even program file, I think it's just C get. Maybe unless
No, Windows, it's Windows.
Windows get actually.
Because I saw the installation slow.
No, get il client di Ethereum.
Yeah. You can also you don't have to run it like this.
No, but I can run it.
You can run it the full path. Yeah, it's the same thing. Yes. Yeah, that's also an option. Yeah, that's true. Does anyone else have any problems? Yeah.
sati samo, trebamo, kad trebate, nije nešto koje treba voditi. Nije nešto, znaš što
Trebaju u srijedu.
tebi treba za srijedu.
I sati za
Da. Ja znam za sate za projekte, ništa ništa
čovjek naš već ozbiljan, zreo, dugo sam tek ja nešto. baš na 5. To zimi da ovo smo na tome teško da je neko može biti dobar tehnički i humanistički. Znači, znaš, ono, kod mene matematika ne ide u jezici, a ne ide u hrvatski, engleski, ili ono ide u jezici, a još tu ide i likovni, tjelesni, sve interesno. Mislim, on nije želio ići, on na to ligi već, ono prati.
Okay, I think we're ready to continue now. So now we made new accounts, and we are ready to create our Genesis file. The Genesis file is, like I said, the file on which the Ethereum blockchain is built. So that's the seed from which the tree grows, and we'll be building it by just running Puppet. So once you run Puppet, it'll ask you some questions, and in this case we can just all follow the same instructions, but then I'll make one Genesis file which we can all use, because if all of us add our own addresses to the Genesis file, then everybody's going to have their own blockchain. This is not what we want. But for demonstration purposes, we'll all fill it out together, just so I show you what it's about. So first, you enter the network name. This can be anything. This is used to differentiate these Genesis files. They will be named like you named the network. So in this case, block split is fine. Now it'll ask you what you would like to do, and this is the second option that we need. We need to configure a new Genesis file. You don't have Puppet installed? Do you have Homebrew? Homebrew. If you type brew, B-R-E-W. No? Okay. Who else doesn't have Puppet? Okay, cool. No, Puppet is a get tool. So you can, if you run brew install get, you should have Puppet. Do you have Puppet? Cool. Na Windowsima je uz one development tools. Znači mora biti ono get and development tools. Da. Da, development tools.
So, excuse me, he's got like windows inside of the computer. I can help him.
Can you open the deck? nth hash is the proof of work algorithm that Ethereum uses. So this is the mining algorithm where people compete and spend a lot of computing power. We'll use the other one, click proof of authority. So here we have the number 2, which is this. How many seconds should blocks take? In proof of authority, in proof of work, the number that it takes, the time it takes to mine a block depends on how complicated it is to mine a block. So if a lot of miners are working, then it's harder, difficulty goes up, and it takes longer. But in general, the system auto-calculates how much time it needs to be around 15 seconds always. In this case, since we're using proof of authority, we can set it as exactly 15 seconds because we are all in agreement that we want the blockchain to work for all of us together. So 15 seconds default is okay, just press enter. Which accounts are allowed to seal? So these are the accounts that will be able to verify transactions. In here, you add the part without 0x from the addresses that you generated previously. So this is where you paste first one, then enter, and then the other. This, ja, adresa, to. Druga. Trebalo biti u historiju od terminala. Nema veze. Samo napravite iz početka od vlaka. Znači, samo brišite sadržaj iz strata 1 i strata 2 i iz početka accountova i onda zabavite adresu, to je to. So after the third one, you can just press enter to cancel this. And now it'll ask which accounts should be pre-funded. Any accounts added to this list will have almost an infinity of ether in them. So that's so many numbers that it doesn't fit in most wallet interfaces. Why? Because there are no mining rewards in proof of authority. In proof of authority, when you mine a block, you don't get a mining block reward. In proof of work, you do. You get 5 ether, and if you're the second one to mine a block, you get 3 ether, and so on. In proof of authority, there are no rewards. The only reward you get is from the transaction fees as you execute transactions. And if you don't have any ether in your account, then there's no way to do transactions because you have nothing to pay for the transactions with. So any accounts that should be able to execute transactions should be added here. These will be the same ones as we just said for sealing. So the same thing.
Both or one?
Both. This is optional. You can always modify this later because it's not. I mean, you can just fund one and then send ether to another and so on. As long as one is funded, your network is fine because this is really such an amount of ether that it's absurd. Okay. So now it'll ask you for the chain network ID. When several private blockchains are running on the same network, and this can happen in large development teams, there are these network IDs. This is just a random number that you use to identify which network you're connecting to. If, for example, another workshop connected to our own Wi-Fi, nodes, when Ethereum nodes are connecting to each other, they use a gossip protocol. And this means that when one connects to the other, if this other is connected to other nodes already, the first one is automatically connected to those. So in Ethereum, this connection spreads virally. When you connect to one, it connects to others, and so on. So if another workshop was using this and it found a node on our network, we'd get connected workshops if we were using the same network ID. This is why the network ID will be different and random, so just pressing enter is fine here. It'll produce a random number. And that's all there is for the Puppet configuration. Now all we have to do is export this Genesis file so that we can generate our blockchain from it. This is again option 2, and export Genesis file.
Sorry, for me it's different. Like after specify your chain network ID, it was like anything found to be embedded into the Genesis block.
I don't know, just press it.
Okay.
Now go to manage. Again, option you should all have the blogsplit.json file in your folder. You can exit this by just pressing Control C. So if you check your folder, you should have data1, data2, and blogsplit.json.
Yeah.
Does everyone have this? No?
I forgot to remember all those commands for generating the key.
Sure.
So,
Yeah, sure. So, yeah. Minus data.
Evo.
Okay, now we have to install Truffle, which will help us develop our smart contract. And this is done, it's best to do this on a global level for your entire computer so you can run it from anywhere. And this is easily done by running npm install -g for global and just Truffle. So run npm install -g Truffle, and that's going to install it globally for your entire computer. So you can run it. So you can run it from any location, including our folder where we are building our project. For Windows, you should. For Windows, it's the same thing. Same commands, same everything. Should work. Because it's npm. You downloaded npm when you downloaded Node.js, and if you download Node.js, you have the recent npm, which will install this regardless of. If you get this warning about updating npm, this is a lie. Don't trust him. It doesn't. It never works.
Is there any command to go out, to get out from
Control C.
from get?
From get, yes. Control C.
Control C.
Yeah.
But it's on Windows.
Yeah.
It's not
Are you good? Do you need help with the Puppet configuration? Yeah. Okay.
So check this with.
This is fine. This is good. This is good. This is fine.
Ok, sad sam tukaj na zastupu stranu pitaš to dovoljno.
Aha, ovo je sad continuous proces. Ovo je početak. Znači ja uputila split.
Treba i brisati ovo.
Sad znači npm minus npm install. npm install.
Public blockchain, national blockchain.
To je ova installirana
Ja, jak tutte le aziende
Provate a mescolare
logistiche si possono creare una blockchain solo con
npm install means git.
sudo.
All right, so we installed Truffle. Truffle is, like I said, the software will help us develop the token. But first we have to run our nodes and connect our nodes together so that we form a blockchain. So let's do this. Let's do this. Let me just first. We'll have to share those addresses that you made now, so that I can all add you to the Genesis file, and that we can all be sealers. And then I'll show share the Genesis file with you. I will make a gist now, since internet works, fortunately. Let's go like this. Okay. No.
Disconnect and connect again.
Yeah. Let's see.
What about? Что ты this level?
To vam ne treba još.
But why there are so many addresses in the Genesis file?
I don't know why it generates. It pre-generates several dozen addresses for some reason, and gives them a zero balance. These can also be deleted. I don't know why it does this. Uh-huh. Okay. Right. Well, looks like this is not going to work the way we intended, so we won't be able to connect to each other for now. Maybe later. It's easy to restart a new blockchain later if we can just get a reliable connection. So anyway, for now, since everybody has two nodes set up, we'll set it up so that every one of you has their own private blockchain, and maybe we'll make another one later on that we can all connect together. Right. So for starters,
But
yep.
for me, it's working in that. I don't know why.
Yeah, I don't know why it works for some and some.
What about if we do like a paste bin or something?
Yeah, I mean,
Or
it's not in general, it's not, we
or
can't.
blanker or something?
Oh, it's here.
Now we opened, great. Just when I clicked. Okay. All right, now it works. Yeah. So I am going to make this paste exposure, create with paste. Okay. Okay, please go to this address and can you comment on this if you're not registered?
Sorry?
Is it possible to comment on pastes if you're not registered? I don't think so. I don't think so. Okay, let's do gist then anyway. Okay.
Yeah, I can write.
Okay, file right here. Name. Okay, please go to. Oh Christ.
Can you put in the channel of Slack?
Are you all in Slack? No? Yeah. Okay, I'll try and do it like this then. 1 second.
I think if you just go on your user account on GIST, you should see the public.
Can you do that?
Try, yes, sure.
Can you see it? No, you shouldn't because it's secret. Because it.
I just make it public.
Yeah.
I see one created 20 days ago.
No. Wait. Can I make this? Can I make this public? Make public.
Sure.
Yeah. Okay. All right. Can you see it now?
Just a sec. Yes.
Okay. Please add into this. So go to my account. Go
Just to account, just to
gist github.com/swader
Sweeter, that's it.
and find this gist there and put your addresses into a comment and I'll add you all into my Genesis file and then I'll share it with you.
So do you comment?
In the comment, yeah.
I mean IP addresses, no?
Sorry?
Which address? Addresses of accounts, okay.
Yeah, addresses of the generated accounts, the Ethereum addresses that we generated.
Just check it.
What?
Go
You
to
okay, super.
Commentar.
Uh-huh. So no.
What should we do?
So I'll show you 1 second. So do this. Add your addresses into a comment. Just add them here, so that I can authorize your node to be a sealer. So gist.github.com/swader is the address.
But you must be signed in Git as the reason.
Must be signed in.
NHT account. Git.
Okay. I will sign up.
Or
Okay,
да, копия. Естествено, Git.
Tu su ti developeri koji nisu nisam
Okay, cool.
Absolutely.
Now I have
No, proszę.
Is the internet causing problems again?
Yeah, it's a little slower right now,
Mm.
but I mean,
Yeah, we'll see how
time.
it'll work for maintaining our connection on the blockchain. That might be a problem as well.
Imat će s tim sad. Kažem, šalim, ne? Svi, to.
Oh shit. It's guest.github.com/Sweden, yes. And then the first one. Yeah, but
Može ući aproksimirati koliko ljudi u Hrvatskoj uopće, recimo, koliko uopće aktivno radi na projektima, šta je sa smart kontraktima?
Nemam pojma.
Koliko je to zaživjelo, rašireno?
Širi se, ali jak je taj neki poaching lobby, tako da svako ko malo dotakne to ode odmah. Mi nemamo tu uvida u Hrvatskoj uopće. Ali jako malo. Jer,
Kad neko takne, ode iz toga ili uđe?
ne,
Kad uđe u to?
uzme ga neka firma i ode iz Hrvatske, ne? Tako da mi nemamo tu uvid više.
mislite kad neko zna raditi?
Jer kad neko zna raditi, odmah ode dalje i mi gubimo.
Šta treba znati raditi?
Nije toliko savladavanje toga koda koliko psihička sprema da bude odgovoran za par milijuna eura sam. Tu mnogi onda rađe ne. To je onda relativno. Jer to je
Mislim da nema nešto puno hardcore
Ne.
Pa neke skriptice, pa nešto,
točno to.
environment nodovi, dodaju, uzmu,
Točno to,
shvati.
da. Tu je daleko veći proces, je tu business development i općenito planiranje long term nekog tokena, jer se ne da promijeniti taj program koji se napiše, ne? Tako da je jako teško to updateati. I tu je onda, znači, jako long term razmišljanje i jako spremnost na te rizike i na te stresove koji dolaze s tim da sam čovjek handla više para nego banke rade na svojim sustavima.
Postaneš investicijski bankar na kraju.
Alright, so this is obviously not going to work as planned. Even if we do add each other, it's going to be crashing often, so we better not waste time on this. We will be running each our own blockchain for now, and maybe we'll be able to connect later. So for now, we'll use each our own generated Genesis file, which I will send, okay, which should be adequate for this. So, does anyone not have a Genesis file?
The one the block split in the
Yeah.
No, yeah.
Okay. So, do you have a Genesis file? No, you don't have a Genesis file.
Still in the Get is still installing.
Get is still installing. Through Brew?
Yeah.
Shit. Is it moving or?
It's going, but it was installing some dependencies for the last half an hour.
Wow. Okay. Okay. All right. Let's see what we can do here.
So we can speed this up.
This
u biti možeš staviti ran. Ideš tamo na maju, ti generiraš raun, biti dođeš UTC, koji onda možeš samo ukidati ovdje. Šta vidiš, koji ti je, baš je viš koliko je se ta
their Genesis file, and everybody's ready to launch this. So let's finish this infrastructure step. To launch your node, what you need to do is the following. In the folder where you created this Genesis file and everything, you have to initialize a new blockchain. So an initialization means start a new blockchain from this Genesis file. So it means plant the seed, the Genesis seed. This happens with get. Again, you always set the data dir that you want to use with a given node. So in our case, the first node will be in data 1. Then the command is init for initialize, and then you target the Genesis file that you've built. So this is the command: get ---- data dir data 1 init blocksplit.json. Yep.
So we exited the puppet.
Yeah, exit the Puppet. Yeah. Puppet is done. Puppet is done.
We don't need to do anything.
You don't need to do anything with Puppet anymore. When you exported the JSON file, that's done. We're done with Puppet.
So we are doing this for what?
Both folders.
For both folders. So you do it once like this, and it'll compile the blockchain starter back in this. And then you do the same thing in the other one.
Bruno, pardon my ignorance, but how does this work? I mean, if we just created our own JSON, how does it will know that we're going to connect? We're doing our own.
Yeah, you are doing your own private blockchain on your computer. Later on, when we'll be connecting to the live network, I will explain that part. Yes.
Yeah. Okay. Sorry.
Yeah.
Okay.
So, yeah.
Do all the nodes in one private network needs to be initialized with the same Genesis file?
Yes. If you want nodes to work, if you want multiple nodes to work on the same blockchain file, then you need to initialize them all with the same Genesis file, because they need to be aware. Every node that starts needs to be aware of the entire blockchain from the Genesis file to the end block.
I mean, exactly the same file, or
Exactly the same file. Exactly the same file. All right. Everybody done?
No.
Please do this.
I have some incompatibility issues. That's okay.
What kind of issues?
Says fail to write Genesis block. Database already contains compatible Genesis block.
Is that on the first or second? That's why. Probably because you didn't change the folder. All right. So next up, what we need to do is finally launch the node. And
Can you say it again? Can you show me?
the command. Do you need the command?
Yeah, I have the same fail to read Genesis file. So we have to put.
So the first command is one folder, and the other command is the other folder. So you see here data 1, data 2.
But we need to go inside.
No, you are in the root folder.
On the root.
You are one folder above those folders.
Even if you do,
But blocks split JSON is.
okay.
Yeah.
Still.
So
fail to
the structure.
JSON. Shit. Sorry.
Yeah. So this is the structure. This is the structure. So it's one folder where two subfolders are inside, data 1, data 2, and the JSON JSON file is the same folder. All right. So to launch a node, to actually start it, you also run get with the with the data dir, and you will have to also do this for each of the folders. So again, data 1, and first we need to define the port where node 1 will be running. That's usually that you can choose any port that you think is free. On Mac OS, it's a safe bet to use 3000 and higher. So it'll run on this port, and our first node will need RPC, and RPC is a flag that you pass to the node, which tells it allow web connections to this node. We need this in order to be able to connect with a browser to our blockchain. This is only needed for one node. The other node will not need this because the other node will connect to the first node and will be proxying through it. So we need this RPC, and we need to allow it from any domain. So just put an asterisk in quotes for the course domain. And RPC API, which means that applications can connect directly to the RPC through an API. This is also a flag that's needed.
What does domain here means here?
Domain means from which domains we can connect to the RPC node. So that means which applications are allowed to connect. Since we don't have a launched application, there's no way to know where this is like a domain for remote calls. And RPC API will define which APIs we will add into the node so that we can use them from outside. In this case, we'll define database, Ethereum, net, and you'll see all of these interfaces once we enter the console. We are also going to use Web3. And Web3 is a collection of JavaScript code which you can use to execute JavaScript functions on the Ethereum blockchain itself. So you can use it to send transactions, to compile smart contracts, to query balances, and so on and so forth. Web3, what else? Oh yeah, so to manage accounts on a node, you also need the personal API. So personal. So these are the APIs. You can find these in the documentation, and I will also put them in the source code repository for this workshop, so don't worry about remembering this. It's all very well documented, and this workshop will also be in written form for everything we don't manage to cover today. I'll publish it on Bitfall, so you can read it there, and there will be step-by-step instructions, so you can follow at home. These are the commands that you need to run, and you press enter, and then it will start the node. And you can see here that IPC endpoint is opened in a file. So it generated a file called guest.ipc in this data folder. And it generated an API endpoint on localhost on your machine's server in port 8545. And this is the address and port we can use to connect with web-based wallets like MetaMask, like Mist, like Remix, and so on. You can use this to connect other software to your node and use it from the browser. So this is one node, and now our terminal is stuck like this because it's running this node. So we need to open a new terminal window, a new terminal tab, where we'll run the other node. Again, in the same folder. So in the same folder, you are...
So we have to don't close the terminal, right?
Don't close the terminal, yeah. Just open a new one, leave this one running. Because this will also be useful for inspecting later. You will see how blocks are made in this terminal as they are being written. Yeah. Sure. 1 second. So execute the same stuff here. Get data there. Data 2. Yes, and the port will need to be changed, and the data folder. So port.
Data 2 instead of data 1.
Yes, and port can be 3002 or something. I use that one. And the RPC API, so the API that we'll be able to use from the console, which connects via RPC, will be the same. TH, net, web3, personal, port, RPC API, and that's it. Okay, so this one will start the new node, but you will notice that this one only has IPC, does not have the HTTP endpoint. That's because we didn't want to open another HTTP connection, because the first node is already connected.
No domain.
komand, ostaje sam
RPC with only one.
So, sorry, koji?
prvu komandu.
Aha, prvu komandu, može.
Meni je sad zadnja naredba u tom kad piše nalaz,
Molim?
da ti kaže šta nije u redu.
Mislio sam da prvi
Evo ga.
ovaj je...
Tu je prvo.
to je to.
Da.
Okej.
If I fuck it up one, can I just like Control C and start again? I just wrote like a wrong command in one, like RPC with only one command. Instead of like dash.
Just close and rerun.
Okay, close and
The second one, when I started it, it stopped immediately.
What's it say?
Error starting protocol stack, listen TCP 17001.
Da ti da pomak izviša krene. Jesi da šta se radi?
Ne znam,
Ivana kad prvi put pokrenem ovo.
To odmah ide prođe samo.
Ja, možda malo to. Ne, se nešto opet ok, ali sad treba otvoriti još jednu kodu.
To za ovo drugo, ne?
Da mi je, evo prije
So it comes to this.
Imaš drugu samo bez ovoga RPC i RPC kodu, ne? Isto sve.
Isto i drugo.
Da.
Ali nije isto, kako se sve. Znači isto bez... Bez, evo, drugi, okej, i samo ovaj up.
Trebalo biti to tako, sad ću vam sve nisam
Isto po imenu je.
You got the message access for the second node. Access is denied.
Da li ste maknuli ovaj RPC i RPC course?
Samo smo ostavili ovaj RPC up i drugi
To je-
port
to je-
i
to je-
data dva.
To je okej. Internet. To su Windows problemi. Možda zbog administratora. Možda zbog administratora.
non so, sarà bravo, ci sono tutte le foto di
To se ima problema.
Probaj,
Ja sam nešto slično radio prije 10-15 dana, sam eksperimentirao. Onda kad bi išao otvoriti drugu konzolu, ne bi se mogao spojiti na node, preko konzole sa drugog browsera. Uvijek ne znam zašto, recimo. Razumijete, ono kad pogledate u konzolnom modu, get,
Da.
i onda kad otvorim drugi browser,
Aha.
drugi komad videa, onda se kad ide konzolno spojiti na taj prvi,
Da.
nikad to nisam spojio.
To će nam biti bitno tu, tako da to ćemo morat nekako, mislim da će raditi. Mada, ne znam, na Windowsima vidjet ćemo. Sad ćemo vidjeti koji je ovdje problem. Okay. Um, so it turns out that if you're getting access denied, Windows opens one IPC pipe and then can no longer open any others, even though it's in a different folder completely. The solution seems to be
Not to use Linux.
not to use Windows is one option. Another option is specifying a custom pipe. So if you're getting, I assume the first one works, but the second one is access denied, yeah? All right. So one option, it seems, is using the second node like this. So like this, but you also put in IPC path, and I think you're supposed to put in a custom path. Let me just check real quickly. Okay. Windows updated. Right. So yeah. Okay. So Windows. Windows is crazy. So we should maybe like this. Let's see. No, this doesn't work. What if I put in IPC disable? That works, but it won't let the console connect. Then there's your problem. So IPC disable. Yeah, if you put in IPC disable, then we won't be able to connect with the console. That's the problem. But we can hack around this. Okay, let me try this.
Sì, però non so, cioè se ti fa vedere, cioè sul lato di fermo, non è che sta
All right, try this. So try adding the IPC path flag at the end of the second. So the second node. Try the people getting access denied. Try this. Try IPC path get IPC. See if that works.
Get IPC.
Same thing. Access denied.
No, like memory address.
Nešto go.
Good. That's the other problem.
No, but I have the same access is denied.
Access denied.
I have a problem that data div already used by management version.
Are you sure you put in two different data folders? Data 1, data 2? All right, let me check. Here.
Go routine.
Yeah, that's not good. Ethereum. Um,
Да. Što ima to to.
okay. So access denied probably.
Yeah.
Access denied, access denied.
No, I got a new one.
Access denied or no, memory no.
Now try use Ubuntu.
So
Yeah, memory.
you have Ubuntu?
Oh.
Okay. Okay, you have a memory problem. Memory without. Okay. It shouldn't matter. It shouldn't matter.
No, I can close some.
How much RAM does this machine have?
16 gigabytes. I can-
No. That's
I can
no.
I can running Apple behind here.
Doesn't matter. Doesn't matter. It shouldn't matter. It's a problem in Go with a specific.
Yes, but that's...
This is an open. I'm seeing this as an open issue in the repository. This exact light server panic, kernel panic for memory address or null pointer dereference.
It works now. You just have to put data2 slash get.ipo in IPC path.
IPO.
IPO, yes. Yes, so when you define IPC path, you put the get.ipc into the parents, so
Yeah.
you just have to put the path of this file. So data2 slash get.ipo, IPC, sorry,
Aha.
and it works.
Ah, okay.
So you have to tell where this file is,
Yeah. Okay, so
and now it works.
so this is going to work for Windows.
Yes, almost.
Can you guys try it?
Yeah, endpoint.
Yeah.
Yeah, and using the Linux slash.
Does this remove the null pointer error as well?
Yeah. I put the data2 folder in all the full path. The data2, but using the Linux slash, not backslash.
Okay, this is useful information. I'm going to write this down.
Dobro, ali ja sam nacikljen. Ali nek snimio i...
And when it says that it's open in the console, you get the Windows backslashes and Linux slash on this last one.
Right. So yours works now?
Yeah, it's open. IPC endpoint open.
Cool. Did you find this? Oh, you've changed the OS. You can change back a little bit the stuff, so you don't have to start over. Because you can't start. Yeah, but na Windows I onda ovo metoda. Sve isto sad, samo kad bude onaj error, onda sad samo rješenje. That's interesting. Any other problems? All right.
I have with this, sorry.
With mist?
Yeah, but I got some warnings here. But I'm
Oh, that's okay. Let's just close this message. It's fine. All right. Yay. So now you have two running nodes. You need to let these run in their own tabs, and we'll have to open another tab to connect to a console. Now, a Geth console, is an environment where you enter this node that it's running, and you can run some functions inside it, so to execute some logic. For example, let's in the new tab just type. Oops. All right. So in the new tab, you enter a console of a running node by finding its geth.ipc file. So in this case, we'll enter our first node by typing in geth attach. So you attach this console to a running node, and then you put ipc : and then you enter the path to the IPC file. So in my case, that's data1 and get.ipc. Oops. Message file or directory. That's interesting. Oh, because I'm not in the folder. There you go. So now I'm inside this get node that's running. And you can also connect the other nodes to this as well in the exact same way. So let me just demo it real quick.
You have to open another page.
Yep, open another tab because we'll keep the console open. Get attach. So again, IPC. In this case, data2 / guest.ipc. Although again, I'm out of the folder. And there we go. So I'm connected to both these consoles now. Now I have two entrances into one node each, and I can execute commands inside each of the nodes that is running. The nodes, at this point, the nodes do not see each other. They are not running on the same blockchain. To make them see each other, we'll have to execute another function which will make them find each other, and then the gossiping can take over. If other nodes come into the system, then they will gossip about them and tell other nodes about them and so on. But first connect to the consoles. Anyone having problems with connecting?
Yeah.
Windows? Okay, get. Attach IPC. Though on Windows you might need to use backslash. Is there Aha, evo ga, znači tu je putanja do toga. On ima iz nekog razloga su Windows i dobro
Koje je rješenje?
Aha, pipe.
Yeah, pipe.
Instead of data one,
So
pipe.
Windows opens a pipe and not a file, an IPC file.
Okay.
So if you look at your node when it's running, at the end it will say IPC node open and the path will be there. On Windows it's going to say pipe. On every other OS it's going to say an actual path to the IPC node.
To ti ovo. URL.
Za launch node. Za pokrenuti node.
Što ideš na ovu konzolu? Odeš na konzolu.
Jer treba pokrenuti nodove. Da.
Biti to URL na ovoj prvoj konzoli.
Da, samo ovo.
Njega kupiš. I onda kažeš isto ti je samo što napravi IPC dvotočka, tu stazu baciš. Evo meni radi.
Radi?
Što si utrudila se?
Attach. Na oba dva noda.
Sad ćemo probati.
Drugi ima drugu putanju vjerojatno.
Dobro,
Da, uglavnom to je ta putanja koja se stavlja. So use the path that the IPC line gives you when the node is running. Use the path to connect through the attach. So get attach IPC : and then the path that the node gives you.
Želite na ovaj dvotočka i onda odete na ovu kontrolu, recimo mod 1, važno imate URL 1 i onda sve iza URL to kopirate, onda to ne radi.
Ne može
Sad ja ne znam šta tebi čekam za njih. Evo, beta.itc dotočka i taj URL koji mi izbaci node kad se
To je okej, to je prvi mi jasno, sam napravim, ovaj drugi mi se
A ja sam se meni drugi ne isto. Drugi data pravo, meni isto ništa ne stoji, samo taj URL.
Ti ušao u konzolu, onaj, čekaj, ti sad pomalo, da? Okej.
Evo, gledam marketing, to na praktiku, super.
ali ne znam, resetirali smo.
Kako smo rešili access denied? To je bilo na IPC path.
Da,
Je.
sam, tako.
Today's lesson, do not use Windows.
Yeah.
Trebamo nešto modificirati na tom pipe pathu.
Samo kopiramo. Kako izbacila kontrola na pipe?
Direktni copy, bez backslash, bez escape.
Ovako, ne, ovako. Ovo je baš nema kopirati. Ovo je za drugi, ovo je za... Ne, ovo nije.
IPC.
Ovako je bio. Prvi, ovo je za...
Aha, double slash this.
Najbolje da nađete output druge, recimo ako imate problem.
ovi komande u čemu? U git bashu?
Je.
A ovdje je terminal. Je civil, ok. PowerShell je
Okay, GitHub.
Pauza, ručak je u 1, kažu. Do pauze smo gotovi s ovim glupostima, tako da idemo direktno na kod i to onako hardcore odmah nakon pauze jer već smo više vremena izgubili. Now that you're in the console, whoever managed to get in, you can run some commands. For example, you can run something like ETH will expose the interface for commands that you can use on the Ethereum collection of functions inside the console itself. So, for example, you can check. You can see here that once you run ETH, this is actually a JSON object with functions and so on. So this is all JavaScript. If you put in ETH accounts, oops, yeah. All right. So if you put in ETH accounts, ETH.accounts, it will just output all the accounts that are added to this node. In our case, this node only has the one account that we generated for it. If you put in ETH Coinbase, a Coinbase account is the account to which reward Ether is sent on mining and on confirming transactions. This is the default account which is used when the network is using it to send transactions and to get confirmations. Yeah. Yeah. It has nothing to do with the Coinbase as an exchange. They just use this because it's a popular name. And there's a lot of these. You know, there's gas price, there's mining, the hash rate, and so on. So in order to start mining, you have to run the miner, but before that, we have to connect our nodes together. In order to connect our nodes, we have to find the e-node. The e-node is an address of a node on the Ethereum network. So you can get this by using the admin superset of commands. So admin has these commands, and there's all the information inside. So to get this directly, you can pick admin.nodeinfo.enode. So admin nodeinfo enode. I made a typo. Admin.nodeinfo.enode, and you get this enode string, which is used to connect the other node to it. Yeah.
Sorry, just like before this, how did you get to this thing in get?
This is get attach.
Sorry?
This is what you get when you type get attach something, IPC. This is inside the get console. You had to.
But how do you get into the get console? Sorry.
With
I
get.
I ran the two nodes, but they're like only staying there. It's not
Open a
nothing.
new.
You need to open a new terminal and do.
Sorry.
Yeah, and do the get attach IPC something. You skipped some steps.
Yeah. So. Yeah. Yes. This is the e-node is the network address of this node that we are currently in. And on the other console, the address will be different. So admin node info e-node. This is a different one. You know? Yeah. So manually connecting nodes works like this. You use admin.addPeer, and into the parentheses of admin.addPeer, you paste in the e-node of the other node. So you select the e-node that we got here with the quotes.
Is it the same to connect from the first to the second, or?
Doesn't matter. So you get this, and you paste it into these parentheses, and it'll return true if it successfully added a node.
Before data, yes, what they do?
True.
Yeah.
So true is like confirmed.
Like
Yeah, success.
So now we have like a network.
Sorry,
of
yeah,
two nodes.
okay. Yeah.
Two nodes connected together, yeah.
Yeah, this.
Yeah. So now you can check how many nodes are connected. by using the net superset of commands, which is, you can see here, peer count is 2, or net dot peer count should be 1, because you have one peer connected to this node. Sometimes it'll say 2 or 3 because it gets confused, it sees a signal twice or something, but in general it should be averaging at 1 because it's constantly listening to this one other node besides itself. So now these two nodes are connected, and you can see the same thing in the other node.
For me, it's peer count 1.
Net peer count 1 is good, yeah. Net dot peer count. The other one has 3, and now if we try again, we'll have 1. So each of them has to have net peer count 1, which means they're connected. I have one peer, you have one peer. That's it. They have each other. So now they are connected in the blockchain. Final step before we run the blockchain is running the miner. And you run the miner by just executing miner.start. When you have the proof in both, so each will mine. Because each is allowed to confirm transactions, each of them can mine on its own. And they will stay in sync because they are now connected via the network. When you have proof of work, you can put the number of processor cores into the parentheses to influence how fast, how well it's mining. So you can put in 1 or 2 or 3 here.
Also, how is difficult to mine?
No, not difficulty, but how effective your computer will be. So how much CPU to use. In this case, this is not necessary because mining on proof of authority takes absolutely no CPU power at all. So you can just mine it at full power, miner start, it'll always return null. And you can run this in both nodes, in both consoles. So miner.start. And you should see a change in your node, which is running in the other window, in the other tab.
Yeah.
So this will now tell you that it started mining. There we go. I forgot one step. So it'll say authentication needed, password or unlock. It cannot mine before you unlock the account that you're using to mine.
The authority, right?
Yeah, the authority. So in this case, we'll do this. We'll first stop the miner, miner.stop, and then we'll unlock the account. And the unlocking is done with the personal APIs, so the personal superset of commands. So personal. And if you just type personal, you'll see which commands are available. But what we're looking for is personal.unlock account. And in parentheses, you add the address which you're unlocking, and you don't have to paste in the full address. You can just type eth.coinbase, and it's going to replace it with the actual address automatically.
And why the Coinbase is not the personal one?
Because the Coinbase one is the one that we set as the sealer in the Genesis file generation. So when we were generating the Genesis file with Puppet, we were asked which accounts are allowed to seal. And one of those is this file, the Coinbase account of this node.
So which one is allowed to?
Seal accounts, seal blocks, that means mine. Which one is allowed to mine? So you have to unlock the one that's in charge of this node, and that's the Coinbase one. That's the first argument. The second argument is the password. In my case, that's internet 2. And the third argument is length, duration of unlock. So after how many seconds it will expire and lock again. If you put 0, that's keep it unlocked as long as the console is open. And this is now unlocked, and now you can do miner.start. But first, let's also unlock the other one. So personal unlock account, and you have here ETH Coinbase, turn into 0. This is wrong, like this. All right. So, yeah, okay. What? Where's my typo? Oh. Idiot. There we go. And now you can just start miner.start in each of those again.
Sorry, what is internet 2 here?
This is my password. My password for these accounts.
Naš koji se stavio u
Okay.
What about about the attachment again, can you show the command for attachment?
Sure, yeah. So you see here, this is now mining, and it's waiting for blocks. Signed recently must wait for others, means someone else mined the block and is waiting for syncing. So they are now mining together, though this is display very properly to that block. We'll see if this triggers now in 21, in 15. Every 15 seconds it should make a new entry. In this case it didn't, so we'll just restart the node because we had this kerfuffle with the unlocking accounts, so we'll just start it again. This can happen. So here we have one node, and here we have another node. The consoles are now effectively dead, even though they don't look it. So we will exit those as well. And now, we run one. There we go. We run the other. There we go. And now the attachment command is get attach IPC : and then path to the get IPC file from the previous. You'll be able to see better here. Yeah. So get attach IPC : and then path to the get IPC file of that node. Because every node got its own IPC file when we started the node.
Okay.
And you can see this path in the node's terminal when at the end of the output. So if you look at the bottom of the terminal output, it's right here. It's IPC endpoint opened, and you'll see the path. So the node you attach like this, IPC, get IPC, and here get IPC. So now we're connected again. Again, we have to personal unlock account, ETH, Coinbase, internet to 0. This, and we'll do the same thing in the other console. This. Okay, so miner.start, and our node is already doing something. Now let's miner start in the other one. Miner.start, and now the other one is doing something. But we forgot to add the peer, the add node peer. We can do this subsequently, like this. So admin node info enode. Okay, and admin add peer. Alright, there we go. And that should be it.
After miner start,
Mine start, no.
Ali evo, to se ja primijetio da je kao neki bug se ponaša prije, kako se radi, taj miner start now. Znači, onda bi samo resetira, znači, ponovo resetira konzolu, ponovo se spoja konzolom i pokrene miner start i onda mi radi.
Da. Yeah. Sometimes you have to start the node multiple times. It's still buggy. This is all beta software, and it's going to be beta software for a long time. So you just have to keep trying. It just happens. Did everybody get to this stage?
No, I just managed to add peers, but what next?
Next, you need to, after you add a peer, you need to unlock the account and you need to start the miner. So,
Both.
in both sessions. So first unlock the account in both sessions, then start the miner in both sessions. This is how you unlock the account. So personal in the console. In the
Does it
console.
matter if we unlock account first and then add peer?
No. Personal dot unlock account, and then either Coinbase, your password.
What are these? Coinbase.
ETH.coinbase is the default address of this node. So the address that
Did I put this somewhere?
yes, when you generated a new account. You know when we were doing get create account new,
Yeah.
that's the account. So it will automatically be embedded in this node because you created it in that folder. That's the key store file that was generated.
I was able to unlock the account for the first session, but first node, but for the second node I'm getting the message error. Database must be explicitly specified.
Ah, okay. In that case, you should probably define your. For some reason, your node didn't remember the. Your node didn't remember the address for the.
Database address.
For database address. So you just do personal dot unlock account, and in parentheses you put the actual address.
Okay.
And then you have another command which can do this. Let me just. So you have this command which you can use. This. So you can assign the default once you add this Coinbase.
Add peers. Peer? Yeah. You need to add a peer. Beer, yes, is better. Beer.
Guess what? It's still not open. Does it work? What did you do?
I just exit console again. And then so we started. They sent it sometimes.
But like this one or the one on
The two other.
Yeah,
phones. So I set the new batch again.
Čeković, zanimljiv.
Add peer, unlock account.
Privatno govorimo i zavodimo se. Samo na internet stavi službu.
so this one.
Touch again.
Da.
Touch again and then the other one
Ще vidi veliko. Ja, samo ne stati u miner stati
To je razlog da
na mom sustavu. Što mi radimo? Što mi radimo?
ne radi, ali
da li instrument preko admin appear? Treba admin,
But you need to open actually the gap, and then you will say admin appear appear and then paste.
Problems?
Yeah.
Yeah.
Get the touch was personal.
Ne, ovo je sad ovdje. A ne, dole sam došao bez problema.
Just appear in one part.
Manja stavka, ako vrati ovo nul, to znači da nije dobro nešto.
Ne, to je okej. To je okej. Je. Nul samo vraća jer nema niz dodataka. So the minor start function returns null because it has nothing to return. It has nothing to tell you.
But it started.
It started, yeah.
Okay, then great.
Null is good, yeah, null is good. So now your nodes should be producing blocks. If they don't, like mine don't, then they didn't connect correctly and something's wrong, so you have to just keep trying to connect them until it works. It's just the nature of this.
For me, nothing is changed.
Yeah, that's the same thing. That's the same problem. Exact same problem.
One question.
Yeah.
What blocks they are creating if there are no transactions which are coming to
If there are no transactions which are coming, then the blocks are empty. So they are mining empty blocks. With confirming transactions, you take transactions, you confirm them, you send them into a block, and you hash that block. But in this case, they hash an empty file, and that's it. Let's see. So we have this one, and we have this one, and we have this one, this one. Is anyone successfully mining? Yeah? Cool. This is good. And this is good. And I'm waiting for that. This. Good. Okay. Running. Good. Set up here and miner start. That started. Signed. Imported. Okay. Now this is going to work now because this one successfully imported a new chain segment, which means they're connected and they're taking the blockchain from each other. And this one miner.start. And now they're both working. Commit new mining work. 3:06, 15 seconds later, there should be a new block, which will get propagated to both of them. There we go. At 21, mine potential block, successfully sealed new block, and the other one got this block and imported it, and now they're building the blockchain together. So now our nodes are working, and you can leave them on, and it'll.
How did you do that?
So in the get console, you just restart nodes and the consoles. So you just have to keep trying to restart them because they will break just like that. And then you, in order, unlock the account, add the enode peer, and then start another one.
In each one,
In each one.
together. Like unlock the account.
You
but
can
Unlock the account,
like
add peer, and then start.
Can you put back the other
Yep.
where there is all the information so we can try
Sure.
50 to 70 times?
Sure. Okay, so let me just type it out for you in a file. Maybe
Yeah, a little bigger.
maybe that'll be better. There we go. So.
So for restarting the node, I have to do like get data here, data one.
Yeah.
And in one, we have to put RPC cross domain.
Yep.
Another one.
Yep. Okay. Run
You should
node
restart all four.
1. If it doesn't work, yeah, just Control C on all 4, and then try turning on all 4 again. So node, console.
Okay, so
Yeah.
all four.
Yeah, all 4. Yeah. You can exit the console just by typing exit, and you can exit the node just by Control C. And so I'll just put in all the instructions here, so you can just repeat them as needed. There we go. This is this. And node 1 is this. Run console 1 is attach see data 1 which does not RPC. Console 2
You say to me connection refused.
where?
In the second, unable to attach to remote jet.
Unable to what? To attach?
To the remote.
Okay, I'll check it out. Check it out. What else is there? So, personal unlock account. Coinbase +0. And node 1.
Maybe this get attached. Right? This is for the node.
then unlock account and confirm node. And miner dot start. No, this should be the procedure. Do this. This is the full process for running the nodes, running the consoles, combining them, unlocking the account, adding peer, and starting the mining.
So I did. Okay. This is Tada 2, Tada 1 now. Tada 1, Tada 2. This is
Also one. Okay.
then I have to write.
And now, first of all, unlock account in both of them.
You can use
Just need to start, so unlock. No, there's no changing password. Onda može ovako, može samo unlock account bez ovog password i nula. Onda će biti življenje. Ne, samo zatvorim zagrada i samo biti za password. Nešto on... Who else isn't mining yet successfully?
I gave up.
Why?
It's easier to
It's
just
eas-
follow your actions.
All right. Well, those who have an active mining going on will be going into coding in the next part after lunch, and we'll just try to rush through it and won't be going through as many details as I hoped we would, but we'll go through it. So those who don't have a miner active, you can try making it work through lunch or until lunch. But if you don't, I encourage you to follow along in Remix, so the browser-based editor. So that way, when you come home, if you open Remix, you will still have the code saved. It'll also save the code for you. And you can also run and deploy it from Remix. It's just going to be a little harder because there's no way to import other files in Remix. There's no way to reuse other people's code without copy-pasting it. And when we're coding locally, we can do that. So we'll work around that a little bit, but it's fine.
You can put this on GitHub.
It's all of it is going to be online, yeah. Is yours working?
Yeah,
And
it's mine.
it's making blocks?
I think yes.
Every 15 seconds should be a new block.
Yeah.
Okay. All good here?
But they are synchronized or not?
The computers? No.
Completely not.
The first and second node is
They mine together.
They mine
At the
together.
same time.
They don't mine together. One of them mines, the other checks the mining.
Okay.
And then the other and so on. How are you guys?
I think now drawing minors are the same. You've done it right. No.
Yeah, sure.
Onda ti imaš koji podržavaju su
That's okay. Shit.
Zato što teški kursi se
No. So happy.
šeranje muzike, teka su istresni ljudi, ništa i onda kad je ovi, ali govori tome, da se mogu, da se to snimi, da se mogu koristiti, da je to svojim citerima i sve. I tam je za prvi godinu dana nekako tehnički dio.
To je ono data 1, data 2, gdje smo stavili key store gdje se spremaju podaci od jednog noda za blockchain. So every node when it's mining, it's saving these blocks that are mined into its data folder. In this case it's data 1 and data 2. Every node has its own folder where it stores the blocks.
Ovo je drugi, a ja ću drugi spojiti na prvi. Dok ja sam samo radio ovo za okrati, ista stvar. Nije to pravo. To je sad idemo sa admin.
Till when should it be finished today?
Right?
Till when should we work today?
Well, the scheduled time is 5 p.m.
Sorry.
Yep.
Getting now for minor stuff generic is possible issue for I just said
Okay. Sad ne manje. Znači oni, na 37. Nije dobro. Znači nisu uspjeli staviti taj šta se biti dva. Znači da nisu se uspjeli snimati. Tu je sad onaj proces da treba pokušati ovo više centralizaciju dobro.
aha, to je dobro. To je dobro. Znači, ti sad meni, on je Node.js NPM treba, pošto me ne hoću pa mi se što mu Node.js tu Node.js pokušaš.
To nemate? Node.js NPM. Ali Node.js i NPM rade na Windowsima.
Nego da cijel proces ponovno nastaje na Macu. Jediniš treba samo i Node.js.
Da. Da. Ne, sa tima možemo do svega. Eventualno mist. Da, sad je više. Okay, we'll take a break for lunch and then start coding immediately afterwards. I have no idea how long lunch is, so just when you see people, how long? Okay. All right, so have 40, so we've finished 10:02, so 40-minute break and then we'll reconvene. You can leave the miners mining if they work. You can just leave them and let them pile up empty blocks.
svima.
Kako znamo koliko ima baterije? Ovo je valjda puno, sve.
To je malo čudno. A bit će ovaj, a ne znam, može on napaja se sa ovim kucom, teško.
Ne može.
Ne može. I reka mi ovaj iz jedini HR da on do sada